This video is for the Unit 2 exam review for Honors Algebra 2. The whole answer key will be on Canvas. This just hits a couple of the problems and some strategies, things I think may cause some issues. So let's look at, I'm not going to do every one, I'm going to do one or two from each set. So mostly addition we're okay. The thing I would remind you to do is somehow keep track of your common terms, your like terms. So if I have 6xy to the fourth, I want to make sure that I mark all of those the same. Some of you underline, circle, whatever you do, just make sure you get those together. Okay, so if I have a 4y and I decide to underline, I want to just go through and make sure I get all the 4y. So 4y plus 6y is 10, 10y minus 2y is 8y. Okay, so I'll let you finish that one. I think we're okay on the addition. Difference, the main issue with difference is always subtraction. Not just subtracting the first term, but distributing the subtraction to every term. Same problem you had in Algebra 1, same problem people have in calculus. They just forget. They get that last term and forget to distribute. So draw your lines, take your time, be careful, don't do silly stuff. Again, I think we're pretty solid on those. Okay, so find each product. Again, this is a distributive property problem. 18n to the third plus 30n squared minus 36n, and then we have 3n squared plus 5n minus 6. Line up all your like terms, works pretty nicely. 18n to the third plus 33n squared minus 31n minus 6. And don't get crazy on this. Some people get all excited and make that n to the fourth. Just, it's worth double checking right there. Some of you, when you check your paper, you just walk up to the place where you turned in and you read through the problems really fast to see if you just left any blank. Checking means go back and check. This is where the mistake usually happens, is right in here. I'll show you this one using the lattice method if you prefer that. Some people are doing that way. So you just write your polynomials. It really works better with a 3 by 3 than a 2 by 3, but basically you're just writing your numbers in here, and this gives you your like terms on the diagonal. So I'm taking 7 to the 56 p squared, so minus 20p squared minus 32p. And so it allows you to simplify on your diagonals. Either way, we don't have a preference. Just we want you to make sure you get the answer right. And I think I multiplied one wrong. That should have been a -8. So this was negative. This was positive, this was negative. Always write the problem down right. So you get 35p cubed minus 76p squared plus 67p minus 56. It always works better if you write the number down. Right here, do not square both numbers and write it. You either need to 8p plus 4 times 8p plus 4, or use the shortcut of square, multiply together, and double. So 32p doubled 64p. If you don't have that shortcut, you can use that same. I don't know which one's faster for you. Division, there's division by a monomial. You can just rewrite and reduce every fraction. So I'm dividing by a monomial, not a binomial. That's a different kind of question. And then I can just reduce my three fractions using the properties from the last chapter. So that's 3 over 1x. So this is 3x. This one, the x squareds cancel out, gives me 4/9. This one, the 9's cancel out, and I have x over x squared, which is 1 over x. X to the -1, depending on if it's multiple choice and you're trying to find an answer. So that would be true for number 10, also a monomial. Number 11, number 12, those are monomials. When we get down to number 13, you could use synthetic division, you could use long division. If it doesn't specify, you can choose either way. You can't use synthetic division for one of these. We did not do the shortcut. There's some kind of technique you have to do. We did not teach you that. Doesn't. So I'm going to do synthetic division first. I put whatever makes that equal to 0, so it's going to be a 4. And then I write the coefficients. And I notice these don't have any that skip powers. But if you skip a power, remember that you need to put zeros, and I'll show you that in a second. Bring down the 1, multiply, write it here, add, multiply, add, multiply, add. There's my remainder. Don't leave this as your answer. The answer would be 1 degree less. So x squared minus 3x minus 7 plus 3 over v minus 4. So make sure you always rewrite it as a polynomial. This is not some kind of secret code. We don't write just those numbers there. Okay. What I was saying before, if there's a problem like if our divisor is x to the 5th minus 3x squared plus 2x, and you are doing this with division, long division, you need to write it as x to the 5th plus 0x to the 4th plus 0x to the 3rd minus 3x squared plus 2x. So you're filling those placeholders. So like if this was synthetic division, it'd be 1, 0, 0, negative 3, 2. Okay, let's do long division. Again, because our coefficient here is not a 1, we'll use long division. And because sometimes we didn't do this, sometimes you can, in your next classes that you'll take, you might divide by something other than a p. It might be a p squared or cubed. Okay, so I see 4p goes into 24p to the 3rd, 6p squared, or I say 4p times 6p squared equals 24p to the 3rd. Once you see it goes in there, you multiply back. So that's minus 12p squared. I put parentheses to remind you of subtraction. I don't change the signs. That way I can go back and check without knowing what was changed and what wasn't changed. I can just look at the picture. So 24 minus negative 12 is 36. Bring down the next thing. 4p goes in there 9p times. Multiply by 9, so I have 36p squared minus 18p. Often people forget where this second number comes from. It's because we're multiplying by that whole quantity there. Negative 30 minus negative 18 is negative 12. It's minus 3. So I have negative 12p plus 6. 5 minus 6 is negative 1. So my remainder would be negative 1 over 4p minus 2. 6p squared plus 9p minus 3 over negative 1, or plus the negative 1 over 4p minus 2. Last one I'll do is a binomial expansion. So either one of these is fine. We'll do the 2y plus 1 to the 4th. So I'm going to get Pascal's triangle on here. Remember that every number is the sum of the two numbers above it. Or you can write patterns if you want to write diagonal, whatever. Okay, so the first thing you do is get everything written out. So I have 2y to the fourth, 1 to the 0. And I know 1 to the 0 is 1, but write it out anyway. 2y to the third, 1 to the first, 2y to the second, 1 to the second. Always powers add up to 4. 2y, 1 to the third, and then the last term is 2y to the 0, 1 to the fourth. And I know 1, it goes away, but this is good practice for if this is something like 7, you have more information here. So, okay, so I have 1, 2, 3, 4, 5 terms. You can memorize where it's at on here, or you can just go, okay, I need the one that has 5 terms. So let's put those in. 1, 4, 6, 4, 1. And now you just go about simplifying. So I have 2 to the fourth, y to the fourth, which is 16y to the fourth. This is 2 to the third, which is 8. 8 times 4 is 32. Y to the third. 2 squared is 4. 4 times 6 is 24. Y squared. 8y plus 1. So there's another video for binomial theorem if you need more help, or the PowerPoint is good to click through. The answers for the rest of this review will be on Canvas as well. Thanks.